Hello everyone and welcome back to lecture 6. In this part of the lecture, we are going to look at different types of heat exchangers and how we can classify them. Okay, so this is not a very technical lecture. This is just to introduce the concepts of heat exchangers and what type of heat exchangers are available, because in the next lecture, we are going to talk about detailed design of heat exchangers. So it is important that we know what are the types of heat exchangers. So, in any chemical industry, heat exchangers are crucial for the process. Okay, so because we are always looking either to heat some fluid or we are always looking to cool some fluid, so it is important that we have these heat exchangers. Okay, so a heat exchanger is a device that actually transfer heat between two fluids, two process fluids. So one process fluid can be, let's say, steam, and you are heating another process steam for the process, like for reactor heating, or you can use refrigerant as a cooling agent to cool down some process steam. And normally this heat transfer happens across a solid surface, okay, or a solid wall. And heat exchangers are very common in a range of chemical industries, like from food industry to chemical industry to petrochemical. Almost every type of industry normally has heat exchangers. Okay. Um, so heat exchangers, some of the common examples are the daily life examples are, for example, car radiators and house radiators that we normally use, for example, to heat our house or to keep our temperature of the car down. Okay. Steam locomotives, nowadays we have electric trains, but obviously in the past we used to have steam, for example, engines that we used to run trains on steam. Then we have air condition and fridges, for example, where we are using a refrigerant to actually cool down the air or cool down the food in the fridge to keep it so that it doesn't go bad. So this is another kind of heat exchanger, okay, for a cooling application. The first kind of heat exchanger is what we call finned heat exchanger. Okay, so this finned heat exchanger is actually just like a radiator. Okay, as you can see, this is a car radiator, and if you look it closely, you can see that there is this the thin metal plate that is actually between different, for example, layers of heat exchanger. Okay. And the reason we have these fin tubes or finned surfaces, because we want to increase the surface area of the exchanger. Okay, so we know the design equation for heat exchangers, like we discussed in the previous part. For example, when we are talking about heat exchange across a surface, that is Q is equal to UA delta T. So A is the area, the surface area of the system, or the surface area of the exchanger. And by making these tubes, these fin tubes, we can actually increase the surface area. And by doing that, we can increase the rate of heat transfer. Okay. And so these fins are actually increase the surface area to volume ratio of these heat exchangers. As you can see that they have a very high surface area to volume ratio. It means for a given volume, they have much more heat exchange area compared to other types of heat exchangers, okay, as you will see in the next slide. And they are very compact type of heat exchangers. The only problem is they are limited to certain kind of heat transfer applications. You cannot just use them for any type of application. And here, for example, how they work in the car. So here you have the engine where the gasoline or the fuel is burning and producing a lot of heat. And then we want to keep the temperature of this engine in control. So we are actually providing it cooling water, and this cooling water is actually go to the engine and then heats up, and then it comes back to the radiator where the heat is actually dissipated to the environment, to the air, and then it cools down. So we really need a very efficient heat exchanger to cool down it very quickly. Okay, and that is why we are using this finned heat exchanger, because it provides a huge surface area to volume ratio. The next type of heat exchanger is what we call shell and tube heat exchanger. Okay, so here what you have a number of tubes inside a shell. Okay, so one of the process streams, for example, the cooling or heating fluid will move inside the tubes, and then the other process stream goes to the shell, and then these two liquids exchange heat through the wall of the tube, okay, and then the shell side liquid goes out, and then the tube side liquid goes through the tubes and then comes out on the top, okay. So by doing that, we actually exchange heat between these two process fluids, okay. And these are one of the most common type of heat exchangers, and as it is like says here, for example, in a typical process industry, around 60% of heat exchangers are actually shell and tube heat exchangers, because they are, for example, they have an optimal surface to volume ratio, not very large, but good enough to use. But the advantage of these heat exchangers are that because they are very cheap, they are robust, and they can be easily manufactured, and they are very versatile in a range of applications, okay. So you can use almost shell and tube heat exchanger almost everywhere, okay. And here you can see another example of this shell and tube heat exchanger in a process plant. Here you can see this is the shell, and then you have a lot of these tubes where one of the process fluids are going to enter and then exchange heat across the wall of these tubes. Here, for example, we have a shell and tube heat exchanger in a steam turbine. So this is from the National Railway Museum in York, where they have this steam engine. And if you look inside this steam engine, you can see that you have a lot of these tubes where the water is, and then you have the shell side where the hot fluid is, that, for example, in this case is actually fume, the flames or the heat from the coal. And then the flames actually heat up these tubes, and the water inside these tubes generate steam pressure, okay. So this is just to show you how it works in real life. So here, for example, you have this fire, and this from coal or from burning the fuel, and it is heating up the liquid inside these tubes, okay. So you can see that it's generating a lot of steam, and then the driver can actually control this steam through this pipe. And then like, for example, here is controlling the steam, and then the steam, he can direct the stream to the piston, and by releasing the steam through the piston, you can generate motion to the train, okay. So this is the principle of steam locomotives, okay. And this can only happen because we have shell and tube heat exchanger here. Then we have the third type of heat exchanger, and that is what we call plate heat exchanger, okay. And here, this is the how it looks like, okay. So you have a number of plates that are very thin in size, and then you combine these plates in a very compact form, and you have between you have the blue one, for example, has the plate that has the cold liquid, and the red one has the hot liquid. So the liquid from, let's say, cold, it goes to the second plate, and then the third plate, and so on. So this is how you heat exchange between these different plates, okay. And as the name suggests, it is one of the compactest form of heat exchangers, and it has a surface area to volume ratio of 70 to 500, more or less same as the shell and tube heat exchangers. But these heat exchangers provide an efficient control of temperature and time. Okay, so these kind of heat exchangers are very common in food industry, especially in dairy industry, where you are controlling the temperature, a precise temperature for a given time. Okay, so these are very good in terms of controlling temperature for a certain time, and that's why they are used in food industry a lot. And also these heat exchangers, because they have very high velocities of the liquid and a lot of turbulence, as you can see, a lot of channels that create a lot of turbulence, and that's why they are they have no fouling, and that's very important for heat transfer. And as we will see in the next lectures, how fouling can affect the heat transfer. Okay.